Hear me. Well, thank you all for coming out to this talk. Thank you to B-Sides NYC for having me. So today we're talking about infrastructure as remote code execution. So quick intro, I'm Mike McCabe. I'm the president of Cloud Security Partners. We're a small firm that helps companies with their cloud migrations, cloud security challenges, application security, pretty much everything in the kind of modern web, IoT, mobile space. So we've done a lot of work with clients who are using things like Terraform and doing cloud migrations, utilizing infrastructure as code. And as a security professional, I'm super passionate about this because I feel like it's a huge benefit to people in a way to really secure their infrastructure. I know you guys just care about remote code execution, so. So what are we talking about? Do people here know what Terraform is or have heard of it or know infrastructure as code? Some of you probably wrote CloudFormation and then cried about that, but Terraform's a lot better. So Terraform is infrastructure as code. So what does that mean? You write code, it is interpreted, and then you create infrastructure out of that. So it's codified, it's consistent, there's a standard API for how you write Terraform. It's free and open source, though HashiCorp, the people who created it, also have Terraform Cloud, Terraform Enterprise. So if you like paying for free things, you can do that as well. So what are some of the benefits of this? So I think my favorite term in this space is ClickOps. Everyone familiar with that? Basically, everyone went to DevSecOps, and now we're going back to ClickOps, which is basically people clicking in the AWS console to create stuff. So this is trying to fix that. This is how you centralize your deployments of infrastructure. It's really mostly focused on infrastructure, not application deployment, so it's not that part of the CI/CD pipeline. But you can deploy consistent infrastructure. So what we've always struggled with is people deploy something, it changes, or they deploy it once manually, they don't commit their code for doing that. Then they deploy it again, and it's different somehow, and we have breaking changes, and every dev team does it slightly different, so you just have a mess in the cloud. So things like Terraform have the benefit of giving you a codified, consistent way of doing it. The other great thing that what I was talking about before is you can apply security controls for preventative measures at that level. If anyone does AppSec, we've always tried to do the SAST model of running tools against our code to try to prevent things like SQL injection or cross-site scripting, all those types of things. You can do the same thing with infrastructure as code, and I'll be talking about some of that as well. What are the challenges with infrastructure as code, and especially Terraform? One of the big ones that we see is Terraform or pipelines are often given really high privileges. So if you right now have your pipeline assigned to admin access in AWS, you're doing something wrong. So if your pipeline can create new users, can modify policies, can do everything under the sun, you're doing something wrong. But that is not very surprising. That's very typical for what we see for people using centralized pipelines to deploy infrastructure or applications. And like the title of the talk, there's multiple ways to execute code with Terraform. Again, it's an infrastructure provisioning. It's not a endpoint provisioning. It's not an Ansible. It's not a Chef or Puppet. It's just meant to provision the infrastructure. It's not meant to do end system configuration. That doesn't mean you can't do it, and we'll get into that. It's also a really great tool as an attacker or a malicious insider to gather information about the environment. And I'll talk about some of the ways you can bypass some of the controls around Terraform as well. So what is our experience with Terraform infrastructure as code? So we've worked with a lot of large financials who obviously have a very, they have a regulatory and compliance regime that means that they have to do things in a very secure, very structured way. And they've moved to these types of pipelines where they're deploying things through Terraform, through CloudFormation, other tools like that. So we've helped them build out basically programs to create patterns and security rules and security tools in their pipelines to deploy out infrastructure in a more secure way. And the reason why I like infrastructure as code is someone who's struggled to help people with AppSec for a long time to kind of reduce AppSec findings, and I've always found SaaS tools and code review just to be not something that scales that well. On the cloud side, you can actually scale this up really well because it is a standard API. Everyone writes Terraform mostly the same way. The providers have their own API documentation. So it is a codified set of things you write against. Therefore, it's very easy to check if something is true or false, or if something is this value or is not this value. So actually, in some of the environments we've done this, we've looked at something like a CSPM, a Cloud Posture Management system, and seen that if they deploy through this Terraform pipeline, if they have all the security controls applied, they have 0 cloud findings. And if anyone has worked in the cloud environment or has looked at one of the cloud security tools, it's all red all the time, basically. So it's a huge improvement for some of these places that have a really big cloud footprint. So it's a very powerful preventative control, and you can map it to your internal and external controls, your CIS baselines, your whatever it is you want to map these things to. It's very easy to do that. So what does Terraform usually look like in a pipeline? So this is kind of this is Terraform Cloud, so this is their SaaS platform, not just the typical Terraform running in a Jenkins pipeline or some random dev's laptop that you see here and there. But it's very similar to any other pipeline. You have a centralized system for source code, GitHub, unfortunately for some people, GitLab. I'm just kidding. Bitbucket if you just are struggling. I'm just joking. But so you have your infrastructure as code there, your Terraform committed there, and then you have a hook from Terraform Cloud or whatever it is, SCM hook to detect changes in your repo. That runs the Terraform plan, and then eventually apply, and then that reaches out to your cloud infrastructure. So that could be AWS, that could be Azure, that could be on-prem. There's a million different things you can use Terraform for. So that's the general kind of layout of how people use it. Either it's Terraform Cloud or just running internally. So how does Terraform actually work? So there's kind of a few main pieces to it. When you write your Terraform, you make sure the formatting is good, make sure to have your secrets in there, because that's how we get stuff done. You run something called Terraform plan, and that's kind of part of the magic of what Terraform does for you. Is it looks at what you wrote, and it looks at what you have in your cloud environment, and it basically tells you what are the changes that it's going to, what it's going to do. Is it going to create something? Is it going to update something? Is it going to destroy something? And that's the kind of plan piece. We haven't done anything yet, but this is what's going to happen once we do the apply. It gives you outputs for what things are going to look like after things are created. It creates a whole dependency tree to kind of show what has to be created before something else has to be created. Determines unknown values, which we'll get into that because that's important from a security perspective. And then once you have that, you do a Terraform apply if everything looks good. And that's where things actually get updated, created, destroyed, whatever it might be. So that's when it reaches out to your cloud APIs, makes your updates, creates your EC2, whatever you're doing. And then what this actually looks like, if anyone's never seen Terraform before, this is a super, super simple example, but this is an AWS EC2 instance. You don't have to give it much in order to get stuff going. It's not a very complex language. HashiCorp did create their own language because everyone has to have their own thing. But it's very simple to get started. You define a provider, you define the resource you're trying to create. In this case, it's an EC2. You give it a couple different pieces of information, the image it's going to use, the size of the instance. And then you run Terraform plan, and this is what you get out of it, which is basically a spec for what's going to be created. So you can see the action is create. It's an AWS instance, which is an EC2. All these other somewhat interesting fields. You can see things like security groups there, key names, that's SSH key. There's a fun one, get password data. So you can see all these individual fields for the resource that you're creating. So that's the plan. And then once you do the apply, this is actually provisioned or whatever you're doing in your environment. And then kind of the final piece of this is Terraform state, which is very important because part of what Terraform does for you is not just provision infrastructure, but also track differences between what you deployed and what's currently out there. So a lot of people will deploy something and then go into the console, update it, which kind of breaks Terraform because the whole idea is to manage it through Terraform so you have everything centralized and codified. But Terraform state is basically that map of what did you deploy, what is the current state, and then you can update that over time. Obviously, when you run changes, that updates. They're also doing drift detection soon with Terraform, and the thing that's most related to security in this is secrets. So any secret that you create in your Terraform obviously has to go somewhere. It gets sent to the AWS provider, in this case, AWS provider, and it also ends up in your Terraform state. So if you're creating an RDS instance and you have a default master password, if you're creating an SSH key, if you're creating secret values in SSM or secrets manager, that's all going to end up in your Terraform state. Which if you're running open source and you have this on Jenkins, or if you have this backed to S3, now all your secrets are sitting in whatever you're having your Terraform state backed up to, which is obviously a pretty big issue. And Terraform, HashiCorp, I should say, the people who create Terraform are very well aware of this. It might be hard to read, but this is a GitHub issue on the Terraform repo. It was opened in 2014. I took this screenshot a few weeks ago. It says commented 20 hours ago, and this is an update from a PM saying, we're working on this. This is coming real soon. We've had 8-9 years to work on this, but real soon we're going to get this. So, and someone said I shouldn't shame the PM, so I'm sorry, Omar, but you put yourself out there. So obviously it's an issue. It's not one that's solved from HashiCorp and Terraform themselves, so it's something you have to solve on your own by storing that Terraform state in a very secure place. And there's actually Sysdig, the endpoint monitoring, the container company. They did an investigation where an attacker actually found a Terraform state, used the secrets in the Terraform state to access other systems, and pivoted basically. So it is a real world threat. And you have to have one meme per talk. I'll give everyone a second. So that's just before we've created stuff, just the kind of Terraform infrastructure side. It gets much more complex. So Terraform is just a language specification. It's just a tool that takes your inputs and creates some kind of outputs. A lot of the magic happens in what are called providers. There's AWS providers, Azure providers. This list right here is not comprehensive, and these are just the ones that HashiCorp creates. There's obviously community providers. People create their own providers. And you can do, if you write a provider to interact with an API, you can then use Terraform to manage it. What that means, though, is any of these providers are huge. They have a huge internal API for how to write code against them. I don't remember the size of the AWS one, but it's hundreds of thousands of lines. So all those APIs have interesting edge cases and things you can do with them. So it's, again, when we talk about third-party code, sourcing from open source, we also have to think about, on our infrastructure as code side, we're taking all of this community code and putting it into our environment as well. And there could be malicious, or there could just be dangerous code practices or functions inside these as well. So another fun thing, Terraform obviously has its own APIs. So if you're using something like Terraform Cloud or Enterprise, it has its own set of APIs. The one that terrifies me the most is, as I talked about with state, it is a representation of what you have in your environment, if that's cloud or otherwise. The thing I always think about is you can do something called a Terraform import, where you import current running state into your state, and then you can manage it through Terraform, even if you haven't provisioned it through your Terraform. I just always think if someone could import a production, all production RDSs into their state, and then run Terraform destroy, the havoc that you could create with that. So these APIs are obviously pretty privileged. You can do things like manage state, you can do runs, you can do all kinds of things. So it's another attack surface within the Terraform ecosystem you have to think about. Terraform logging, this is a fun one. This is something we're dealing with a client right now, which is Terraform obviously has to have credentials into your environment. And I'm not sure if people know what that is, but basically right there is an STS assume role session. So when Terraform assumes a role to work in your environment, it has to get credentials back from Amazon to assume that role to then interact with the APIs. All of that is dumped out to the logs if you have verbose logging turned on. So if you allow developers, if you're using something like Terraform Cloud or Enterprise, to set a variable, they can dump out the STS role and then have direct access to whatever role you give Terraform. So that's another area that you have to kind of worry about, and this is true for things like secrets as well. You can dump those out to logs, and it's another area that you have to lock down and think about when you're building kind of your threat model and your user privilege model for Terraform. So with all that said, for use by competent people only. So that's kind of the lay of the land with Terraform. I wanted to talk about some more malicious use cases and ways you can abuse Terraform in an environment, either a malicious insider or an attacker who gains access to a pipeline or just to a Git repo that's hooked up to a pipeline. There are dozens. These are just kind of techniques that we've found and we've helped lock down, but there's dozens and dozens of different ways you can use Terraform and either the built-in APIs or the provider-based APIs to kind of do different malicious techniques. So these are just some of the ones we're going to talk about, but there's a lot more. So this is not a complete list of things that you can use to abuse Terraform. The first one up, remote exec. So like I said, Terraform is not meant to be like a systems provisioning tool. They actually have one called Packer, which you create images with it. You can reference those images in your Terraform to build, EC2, like Linux images, things like that, or containers. But Terraform is not meant to be that endpoint management system. You take an AMI, you reference it in your EC2 config, and that's how you move forward with Terraform. But they do give you a few options. HashiCorp very strongly says, don't use these, but we give you these options, which is really handy. So remote exec is basically a way, it's like an Ansible provisioner where you can run scripts on the endpoint. So you boot up an EC2, you run remote exec, and you can run whatever you want to as that user on that EC2. And this might not be relevant for maybe places that don't have a huge amount of kind of security controls when it comes to endpoints. If every one of your developers has root on every one of your production instances, you don't really care about this. But we work with a lot of financials where they do care about privileged access management. They spend millions to make sure that developers can't run things randomly on production instances. And this kind of bypasses that. So really in this example, creating an EC2 instance, logging on, and then running netcat to get back out. So if you're thinking of a malicious use case, someone has access to Terraform, they can't get onto the actual endpoint, but they could provision an EC2, run netcat through remote exec, and then get remote access back into that production server. Like I said, this is basically a way to run any kind of script you want on that endpoint that you set up. So it's a great way if you can't get remote access into a production network, if you'd actually do have privileged access management well managed and people can't just get access into production. This is a great way to bypass all of that. You could do pretty much whatever your user has rights to. So if you want to uninstall CrowdStrike, if you want to uninstall whatever kind of endpoint tools, if you want to run scripts, if you want to get a remote shell back out because no one does egress controls well, this is your tool to do that. And this is built into Terraform. This isn't something you have to get a custom provisioner for. This is all part of the base API. So if you're using Terraform right now, you can write Terraform to do this. So that's one of the techniques which we usually lock down, and I'll show some examples of how we lock this down in Terraform pipelines in environments we work in. So similar, local exec. So whereas remote exec is working on the remote instance, the EC2 or whatever endpoint that you're creating with your Terraform, local exec runs where Terraform runs. So in some environments we've worked in, again, you give Terraform a privileged role to do what it needs to do, and then you either do AppSec reviews on the Terraform, you run SaaS tools, you run different kind of tools that I'll kind of talk about to lock that down. But then local exec basically gives a developer or malicious insider or whoever it is the ability to run whatever they want to run as that Terraform role. So remote exec works on the remote endpoint, local exec runs wherever you run Terraform. So again, you can run basically whatever you want to run. So shell scripts, Python, whatever it is. In this case, we're curling the STS, the metadata endpoint, and then curling that out to a remote endpoint. So the idea being, if you can run this, you can pull out the STS session for the Terraform runner, and then send that off to whatever host, and then you can run that externally outside of the environment to do whatever you want to do. So the problem with, you don't want to mix scripting and Terraform together. They're two different concerns. You have AppSec pipelines that deal with some of these malicious use cases, and you have Terraform pipelines that deal with Terraform. So when you start mixing these two things together, it gets really messy. But there are some tools that can help with this. How many people are familiar or use SemGrep? Yeah, okay, cool. So SemGrep, as in the name, it is a pattern matching tool, obviously much more, I don't know if I'd say more powerful than grep, but meant for a certain use case. Very easy to integrate with pipelines. It's pretty fast, it's open source, and they have a lot of open source rule sets as well. So a really simple example, hopefully you all can read that, but you can write a simple SemGrep rule to check for all these types of things. The great thing about Terraform is there's not a lot of obfuscation. You can't obfuscate kind of what you're doing. You have to write it, and that means you can run tools like this against it to check for it. So in this case, I'm showing on the right the Terraform example of local exec, and on the left a super simple SemGrep rule to basically check for a provisioner and break this. So if you have, even if you're not using something like Terraform Cloud, if you're running Terraform in a pipeline and you have your code being committed, you can run a GitHub action, a Jenkins, whatever Bitbucket does these days, I don't even know. You can run an action to basically run these kind of checks against it and make sure that people aren't introducing malicious Terraform into your pipeline. I'm sorry, here's a zoomed in version. So again, it's super simple to write these types of rules and prevent these types of use cases. So those are kind of some of the ways you can run code, but there's other things you can do. Again, we see places that give a very wide role to a Terraform instance, and what does that mean? Well, there's data methods within Terraform. There's kind of resources, which are what you're creating, and there's data, which is what you reference. And that can be things like SSM parameters, that can be DNS lookups, that can be the state of different resources. But the great thing about if you give Terraform a really wide role is it can pull all that data out and give that to whoever's running this malicious Terraform. And there's a lot of built-in providers and just resources that Terraform gives you that can be used as methods to get that data. So here's one. Here's an actual data method. It's HTTP, so basically it makes a GET request. It's not fully featured. It's just a basic GET request, and it can't do a whole huge amount. But again, if people are familiar with the metadata service that I referred to before, you can hit that metadata service and pull those STS credentials out for that Terraform instance. If anyone has heard about the Cap1 hack, that was someone using SSRF to get the metadata credentials and then using that to kind of pivot elsewhere. So this is a data lookup that you can then get credentials with. But there's a lot of different ways you can use data lookups to get more interesting information. And here's just an example of what that would look like. Fun thing about this too, and I'll talk about this, but this all runs at planned time, so not at apply time. And that's important when we talk about some of the tooling that's out there. But you can see we're able to pull out this data and output it to the plan. So again, the solutions for this are super simple. If you've written SemGrep or if you've written grep, you can write these rules to prevent this type of behavior. It doesn't have to be super complex. It's very basic patterns in Terraform, so it's very basic SemGrep rules. But there are other ways you can abuse this too. This is the fun of Terraform. There's just so many APIs you can use to kind of gather data. So this is an external data call, which you would think the data means data, not data means running code, but not according to HashiCorp. So this is external data where you actually can point to a script, in this case, a Python script. And you can see on the line 5, what we're doing is we're pulling in a data reference, which is a secrets manager secret. And then the Python script could just basically exfil that out. So use the Terraform role to pull out data out of secrets manager, and then use your script and external data to exfil that. So again, really simple examples of how you can abuse the built-in Terraform APIs to exfil data or gather data. So how do we go about preventing this in a more complex scenarios? So SemGrep is great. It's super simple to get started. There's already rule sets out there for different resources, so I definitely suggest checking that out. But if you want to do a more in-depth kind of testing against your Terraform, you kind of hit some limits with SemGrep where you want full code logic. There's a couple solutions out there. I'm sure people have heard of OPA, but Open Policy Agent, there's a language called Rego. If you want to break your brain, go read about disjunction in Rego. If anyone doesn't know about that, it's just crazy. But it's an open source, standard open source language. You can write Rego to do a lot of different things besides just Terraform, but it does have Terraform support. HashiCorp also has their own tool. They sell you the sickness, they give you the sickness and they sell you the medicine, right? So they have their own tool, which is called Sentinel, which you can get as part of Terraform Cloud or Terraform Enterprise, which is somewhat similar to OPA and is meant for securing Terraform. So what are some of the benefits of policy as code is what these tools are called. You can write very fine-grained checks against your environment. They're embedded. You can write multi-cloud rules. You can get external information. And both of them, I think they both offer ways to do basically like hard mandatory, soft mandatory rules. And so what do these actually look like? So this is an example of Sentinel. I would say it's like similar to Python. Sorry if there's any Pythonistas here who hate me for saying that, but it's a very simple syntax, very simple language. You do some simple imports. You define kind of, in this case, the size of an EC2 instance you want. It checks the plan, what we talked about before, finds those resources for an AWS instance, and then does a filter to basically say, are there any instances that have the incorrect instance type? So again, this is 16 lines of code with white space, and you're basically able to lock down kind of the sizes of your EC2s. So they can be very simple and very powerful. This is a somewhat more complicated one, but still not that complicated, where you're just validating the role. So again, these are simple rules that you can do pretty powerful things with, and this is how you build a really hardened infrastructure as code pipeline to make sure that things don't go out the door in an insecure way. And we've also written rules in Sentinel and OPA to do things like prevention of remote code execution with remote exec or local exec or data lookups. You can do all of that there as well. But one of the problems is SemGrep is a SaaS tool. It runs against the actual Terraform, runs against the HCL, their language. These tools run against the Terraform plan, so against the generated structure of what you're going to create. And like I talked about before, you have Terraform plan, you have Terraform apply. Then there's these things called after unknowns. It makes me regret not putting a Donald Rumsfeld. There's unknown unknowns, but after unknowns. So Terraform does a best effort to basically say, okay, here's what the current environment looks like, here's what we're going to create, here's what we're going to update. But then there's some things it can't know at plan time. So things like ARNs for newly created resources, references to some resources can become after unknowns. If you have these like very referential relationships between modules, that can become after unknown. So what is the problem with things being after unknown? So if you think about your Sentinel or your OPA that runs on your plan, if these values aren't known, how do you validate those those things. So it's basically a way to bypass all of your security controls at that point. So if you run a Terraform plan, but all these resources, in this case, there's an ARN that's after unknown as true. If those are after unknown, your checks don't run against them, or they just don't come up as being a violation. This actually was brought up to HashiCorp with one of our clients too, and they didn't really have a solution. So we had to come up with a solution, which is you actually have to ban all after unknowns in like a very strict way in your Sentinel or OPA to make sure that these types of parameters aren't after unknown, because otherwise you can just bypass everything. It wasn't really a known issue from HashiCorp when it was brought up, so they haven't really thought through how their own tools work that well. So it's another kind of area where you can build your security tools and then there's bypasses on those security tools. So someone could write Terraform to intentionally make something like an ARN or some parameter after an unknown and then bypass all of your Sentinel or OPA checks. So you have to have kind of a balance of your SaaS tools like SemGrep and then your more in-depth infrastructure as code tools like Sentinel or OPA. So what are some of the solutions to some of these issues that we've seen and what we've done to kind of help clients with these issues? Obviously, defense in depth is what we always talk about, and you do need to layer your defenses with these issues. IAM is kind of one of the main ways we build more secure and more siloed infrastructure, but there's a lot more things we can do than that. But to kind of start, IAM, obviously you need to build very strict kind of roles, policies, ways that you have to define the way that you want someone to interact with your infrastructure. So if someone needs to deploy EC2 and RDS, they need to have the rights to deploy EC2 and RDS. If they need to deploy like just an S3, they need just to deploy S3 in their policy. We're not very good at this. Every security review that we do in a cloud environment, it's one of the first findings that we throw up is people have policies that are way overprivileged. They give CI/CD systems, admin access, and then there's no real limits at the IAM level to limit these kind of things. But it is probably the most powerful way to restrict the damage in these kind of malicious use cases is making sure that your IAM policies, roles, et cetera, are properly locked down. And you also have to make sure you're monitoring these changes. It's one thing to create a perfectly structured IAM policy and role, but if these things are changing all the time and you're not paying attention to that, then there's no point. So you have to make sure you're monitoring, especially your roles around things like CI/CD or Terraform, making sure that those aren't changing. And IAM gives you a lot of great ways to restrict how roles are used. There's conditionals on IAM where you can restrict it to an EC2, you can restrict it to an AWS org, to a VPC. So there are ways you can lock this down to really limit the damage of even if someone does get a Terraform role and starts using it elsewhere. And a lot of, when people are adopting Terraform and deploying services through Terraform, a big focus that we do is on patterns. And this is going back to kind of having good architecture of how you want to adopt these services. So how do you want to deploy something like RDS? How do you want to use EC2? And having those patterns really well documented and then having those guardrails called out. And all of those guardrails then become things like IAM policies and guardrails in that. They become Sentinel rules, they become SemGrep rules. And that's how you go from having, your red checkboxes, your red boxes on your CSPM to having all green and no findings. So you have to have really in-depth patterns to make sure that when you're deploying something, you have those security, parameters checked off, which is not always easy. And then hardening your services, it kind of goes hand in hand. So having that baseline for how you want to adopt a service, whether that's EC2 or S3, you have to have a hardened version of that. And that the great thing about Terraform is that you create that once in Terraform, you just redeploy it over and over and over again. And developers or DevOps or whoever is using that Terraform, they get that for free. And they don't have to think about the security necessarily of these services. The next thing, we've talked about this a good bit, but code review. You have to have tooling in your pipeline, both for malicious use cases and for your just general patterns for infrastructure as code. So having automation in your pipeline is great. If someone has the AppSec team that's big enough to review every Terraform change, you're very well funded. I'm very jealous, but most people don't have that, so you have to automate code review. Thankfully, there are tools like semgrep, like OPA. There's this great tool called grep. It's free. It's built into Linux. You can do a lot of damage with just that. I'm sure Windows has something similar. I refuse to learn. So, but you can build these tools in to do automated code review. We've been trying to do this on the AppSec side. I think there's a bigger opportunity on the infrastructure side than on the AppSec side, because again, it's down to a specification that you can write really high fidelity rules against, and we won't annoy developers about false positives. So I think there's a huge benefit there. There's also things like unit testing that you can do against Terraform and against things like Sentinel. For every test you do in Sentinel or in semgrep, you should have unit tests to make sure you have good and bad examples of it, so that it's actually working. That's something that we're not great at in security, is actually doing, developer-like practices, like doing unit testing or regression testing or kind of full feature testing. So we have to get into the practice of doing that with our security tooling as well. And then monitoring. No one has great monitoring. Someone asked me after I did this talk before, how do you monitor it for this kind of stuff? And it's easy if you have your logs turned on super high and you have alerts set up to check for remote exec, local exec, things like that. No one basically does that. So it's easy in practice, or easy in theory, it's harder in practice. But we have to monitor for our infrastructure changing in unexpected ways, like Terraform getting new roles, or someone else using Terraform, or a new trust policy being added. We have to monitor our very trusted systems for changes around them as well. So if people are changing the role for your Terraform infrastructure, then you need to kind of be alerted about that as well. And also just monitor for the things that it's doing in your environment. So if it starts provisioning new resources, you should be able to tell that too, to make sure it's a new resource or a new region that it's deploying, and make sure it's an approved change. So conclusions. I think, despite everything I've said, I think Terraform is a great tool. I think infrastructure as code is a great strategy for us to start provisioning cloud in a more secure way and move away from spreadsheets full of insecure S3 buckets and unpatched EC2s. It is a great way for us to build a more secure cloud environment, especially at huge scale. But it comes with a lot of challenges, as I've talked about. So we have to kind of go into it with our eyes open to know that even though it's relatively simple to get started, there's a lot of work to do around securing how things like Terraform are used. It's a really high signal and effective tool in security. It's not just for DevOps. You'd have to think it through very well, have multiple layers of controls as anything, and then monitoring. So that is me. Thank you for listening. If you want to hear more rants about infrastructure as code, I'm on a podcast called Relating to DevSecOps, if you're really into that. And then I'm the president of Cloud Security Partners, so just reach out if you want to talk about infrastructure as code or cloud security. Are there any questions? Okay, you first.
Got a bit of a comment. When you mentioned self-service, first thing that came to mind is the discussion that's been happening around platform engineering and in terms of developer platforms. I feel like that can be very helpful in terms of separating who has access to run these things. Developers are able to apply locally or plan locally. I'm not sure if you at that level you can kind of eliminate some of those other problems you were talking about.
Yeah.
So you would have to look at that platform in order to be able to kind of apply and control that.
Yeah. I mean, I think when it comes to, I've seen it go both ways. I've seen people go from a service catalog model to a Terraform model, and I've seen people go from a Terraform model to a service catalog model. So it's kind of like people, they do one thing, they're like, okay, this is great in some ways, but we're having challenges here because service catalog model is too strict, it's too rigid. We can't, build out a whole suite of infrastructure with a few deployments. And then Terraform is the other way. You can deploy out everything at once, but it can become more of a security headache. I think there's a balance there. I mean, I think building really good patterns for how people adopt services and forcing them to use those patterns, even if that's more rigid than, say, just giving them Terraform access to run, I think that's the way to move forward. So you have the flexibility of writing code to deploy your infrastructure, but you have those guardrails in place on top of having things like SemGrep or Sentinel or whatever. Thanks. Sure.
How have you seen Packer use for pipelines that create like a golden AMI? Have you seen, how often is Packer used to kind of try and create a reduced attack surface? So for example, in that piece of file, putting a script out, enable file monitoring or disable certain drivers, like IDG driver on Amazon Linux 2 that doesn't have to be there. Do you ever see that type of attack surface reduction in Packer builds?
Yeah, I mean, do people use things like Packer or other kind of golden image systems to reduce? Yes, I would say yes. Are people using Alpine images to deploy everything? In certain cases, yes, but I think it's always a trade-off between security and actually having applications or whatever else it is running. I think it's kind of like entropy where people trend to, okay, here's a super lockdown image. Okay, we have to add this. Okay, we have to add this. We have to add this. This breaks here. So yeah, people definitely use it. I wouldn't say it's quite perfect, but it definitely helps reduce the attack surface. There's a lot of people who just take Amazon Linux and run that straight, and then might have some EDR or something like that on top of it. So, sure.
TFSec, TFScan, thoughts on them?
So I'm they're good projects, definitely. They have a good rule set. I'm a firm believer in if you're going to do something, you generally have to do it somewhat custom. From the large kind of environments we've worked in, they've had a dedicated cloud engineering team to build this stuff. So if you're a startup, if you're a smaller company, you don't have the budget to build a whole cloud security engineering team, definitely start with something like TFSec. SemGrep has built-in Terraform rules. These use cases are not actually in those rules, though. I have a rule set on GitHub that I publish that catches some of this stuff. But the malicious use case is not really caught in most of those tools. I don't think TFSec has anything for remote exec or local exec. But it's definitely a good way to get started. I think the problem is as you scale, no one's environment is the same. So you can use TFSec to start, but if you're going to want to enforce tagging standards or naming conventions or where things go in your network, you're always going to end up customizing things. And so you can't use those tools forever. And so then it just becomes build custom tools.
What's your GitHub?
McCabe 615. It's very original. Yeah. Sorry.
You mentioned making the pattern, enforcing that only developers can only use these kind of little patterns with safe defaults rather than raw Terraform. Have you seen any open source tools introduce that approach?
Open source, no, but in projects we've done it. So in environments we've worked in, it's very customized, so it's hard to describe from a just raw Terraform perspective. But you can enforce things like where you're pulling modules from. Again, it gets back to we all trust NPM, we all trust GitHub, we all trust all these packages. Then you have to start ratcheting down to what are our trusted packages and then how we enforce the usage of those. So we've done it where basically here are the modules you can use, and you can't just go to GitHub and use some random module. So if you're going to deploy RDS, you have to use the RDS module, and we have enforcement there. So you can do it with things like SemGrep or Sentinel to basically look where a resource is coming from and make sure that it is coming from that module. But it's somewhat complex. I haven't seen an open source tool that does that for you. So I think.
I'm wondering if you have any thoughts about the CPTF stuff, like the code to Terraform.
I have not personally used it. I've read some Twitter threads that made me feel like I don't want to use it because it's a combination of infrastructure as code in your code, which, yeah, again, I'm not going to say I have a well-informed opinion. I'll just give you a hot take because that sounds horrible, and I've just read bad reviews of it. I think they're two very different things. I think you should think about infrastructure as infrastructure and apps as apps. Obviously, there's more overlap than there used to be, but yeah, I don't have any experience with that. Sorry. Yeah.
Can you talk about the trade-offs between enrolling your own Terraform versus the cloud? And sort of another question to check on it, like these attacks actually happen. Can you talk about the types of attacks and the prevalence of people actually using infrastructure as code?
The benefits of using something like Terraform Cloud is you just get your infrastructure. It's like serverless. You just get your infrastructure for you. The nice thing about it is you can have things divided up into workspaces where you can say, like, this app is in this workspace, this app is in that workspace, which is really important if you do things like vertical segmentation, which at startups you don't really care, but at large enterprises there's things like, SOCs where people can't talk to each other's apps, can't talk to each other's data. So the cloud gives you that. It gives you, I'm not going to say it's a lockdown environment, but somewhat more lockdown than a Jenkins server running Terraform. But then again, you're limited to what they give you in their APIs. There are ways you can run things like semgrep in their pipelines as like a pre-plan basically action, like a GitHub action, but it's their runner. So it's kind of a trade-off of, do you want to host your own stuff and be responsible for locking it down, or do you want to just hand that off to them and don't worry about it? I think there was one more.
Yeah, regarding secrets in State Cloud, what are some strategies for defining that?
So it depends on where you back your state up to. So you define a backend with Terraform. So you can do something like S3. You could do local. I mean, yeah. In the case of S3, treat it like it's a secrets manager at that point. Like, have whatever bucket you use be very locked down, and just treat it like it's your secrets manager. So I mean, secrets manager itself is all IAM based, so you have to treat those policies and those roles with a lot of scrutiny. So it's the same thing if you use S3. You just have to make sure that that bucket is well locked down, monitored, and has limited access to just like the Terraform instance that's using it.
I'm not familiar with what options are for backend, but let's say you kind of have, let's say you are on the subject, would it be a good best case?
Great question. I mean, a lockdown, it's a object, so a lockdown object store. I don't think S3 is bad. The only thing that's bad about S3 is that you click a few buttons and it's now public. So it's an internet-based. I'd say it depends on where Terraform runs, but I'd say it's probably better to have it on a server that's locked down, not on a cloud infrastructure that can be made public. No, like a EC2 or something like that. So, but yeah. Sorry. Yeah.
One of the advantages of infrastructure as code is that there's basically a Git log tracking all the changes. In corporate settings, what threat model are you considering that, like, someone has access to write this code, but they don't care if their, Git user is identified?
The question is, what do you think of, like a malicious insider use case, or?
What is the threat model that you're usually considering in this regime?
I mean, the two that we think of is a malicious insider, which is a developer who has access to Terraform, and preventing them from doing more than they should based on whatever that company's operating model is for developers. And then the other is someone getting access to either Terraform directly or getting access to deploy things out. Again, if they can push to a GitHub repo, if that has automated applies, then they can run Terraform. So those are two of the threat models, and there's a lot of different layers to that. Obviously, you have to think about like someone having server access to Terraform, someone having just API access to Terraform, someone having just access to code. So there's a lot of different layers to it, but those are kind of the two main ones that we think about. So, cool. Anything else? Thanks a lot.